All right, well, thank you very much for staying in. My name is Brian Crawford, as Jess said. I'm a Warnell student working under John Mayers. Thank you for being here as well. And today, underneath this title, what I really want to talk to you about, something a little simpler, how are roads impacting wildlife and what can we do about it? And specifically, we're going to look at lessons learned from this road, the Jekyll Island Causeway, and this species of conservation concern, the diamondback terrapin. But before we do that, I absolutely have to thank my funding sources, specifically Warnell and the Jekyll Island Foundation. And I also want to give a special thanks to the Georgia Sea Turtle Center. They've been our full partners in all these years of research and definitely could not have done half this work without them. So to get started, let me reframe that question and get at the core of what we're going to talk about today. And that is, across the Earth, what do we do when most landscapes look less and less like this, or like this, and they actually look a lot more like this? And if we're really being honest, more often than not, they look like this. So roads are a pervasive human footprint across most landscapes. And as such, this whole field of road ecology and road management has emerged to answer this very question. And so today, I just want to give you our answer to this question. Now, it might not be the flashy answer you expected, but by the end of the day, hopefully no one's asleep, and hopefully I've convinced you this is actually the answer we need. Because models are this crucial link between the motive and the problem behind this research and the management solutions that we hope to produce in the end. So let's get right into it and start with the motive. Roads have been implicated in the declines of many species of wildlife, and the diamondback terrapin is no exception. But to get a sense of why roads are such a problem to them, in embracing the icon mantra of multiple perspectives, let's just get right down to the terrapin's perspective. And this is courtesy of some video of my friend and colleague David Zylo, who studies these guys out of ecology. So, hold on a second, we don't need sound for this. So terrapins inhabit coastal salt marshes. But each summer, adult females like this one complete overland movements, and what she's looking for is high ground onto which she wants to nest. And in these human-developed landscapes, this is what that high ground looks like. So it's important to note, a lot of turtles get to these roadsides, nest, and then go back to the marsh without ever crossing the road. Keep that in mind for later. Others are more like her and choose to put themselves in harm's way, and this is what that crossing process looks like from her viewpoint. So you see, they do react to cars. They're not totally oblivious, but she is a turtle, so she probably forgot a car was a thing by this point. She keeps walking, and they're also turtles, so they don't show what's called road avoidance, and they're not going to outrun anything once they get on the road. So I'm going to stop it there. She did not. She was fine. Somebody asked that the last time I presented. We did not let any harm come to her. So knowing that roads can be a real problem, especially for these female terrapins, we set off to a regional hotspot of road mortality, the Jekyll Island Causeway in South Georgia. And what we did was we entered into a collaborative decision-making process, which Tara did a great job just explaining, and we sort of engaged with a whole spectrum of local stakeholders. And I won't present on that whole process, but to give you a sense, where we are today is just one part of it where we're going to estimate the consequences of different management strategies on the terrapin population. To give you some context and remind you, this follows the stage where we worked with stakeholders and identified what's truly important for them, and maximizing terrapin persistence was one of those things. And then what this is going to lead to is providing optimal decisions for local managers to implement on the Jekyll Island Causeway. So I want to do two things with models today to get us to these decisions. First, we're going to estimate crucial population parameters like survival and abundance. And then we're going to take those parameters and predict the future for this terrapin population with them. Now, both of these are pretty intense. We use some pretty intensive methods. Don't worry, I'm going to keep those pretty brief, but please ask me any questions at the end. But instead, I'm going to focus on how these steps lead us directly to identifying these optimal decisions. So first, all models need data. And through about 6 years of monitoring, we actually collected 2 intensive mark recapture data sets. So at the local scale, we got in the marsh and sampled these 2 creeks adjacent to the causeway using a robust design. And we did mark recapture of male and female terrapins. And this is what those individual marks look like. So then zooming out to the population scale, we did something different. We did road surveys up and down the causeway each summer nesting season, and we did mark recapture again. What we were finding on the road were 3 types of individuals. We found live individuals that were crossing and not crossing the road, and then we also found we recovered dead individuals as well. So using our first modeling method, we were able to take both of these data sets and use what's called an integrated model to simultaneously estimate these parameters. And briefly, what these do is pull information from both models on overlapping parameters. And in our case, this was average female survival. Now we used the creek data to estimate male survival and local abundances, and then we used the road data to do a bunch of really cool things. So first, we teased out the average female survival rate and specifically estimated what's the survival of those crossing individuals and non-crossing individuals. And we also estimated what I'm calling C. It's the proportion of females on the causeway that were choosing to cross the road. And lastly, we used this as a really cool opportunity to estimate the effects of a previously untested and novel management strategy that we implemented halfway through the data collection period. And those were these flashing warning signs. And so by doing these models, we could estimate what happens to the survival of crossing females before versus after these signs were implemented, because they were designed to alert drivers and increase the survival of crossing females. And that's exactly the results that I want to focus on now. So before signs were in place, we estimated that, as expected, the survival of non-crossing females was much higher than those that attempted to cross the road and put themselves at risk to vehicle collisions. After the signs were implemented and activated, we estimated no change in the survival of non-crossing females, which is expected. However, we estimated a 30% increase in the survival of those crossing individuals. And there's a lot of uncertainty around this estimate for sure, but we take this as pretty clear evidence that these signs are having the intended effect and increasing the survival of those individuals. I also want to point out that about half of the females nesting on the causeway were choosing to cross the road. And from our local abundances, we observed very male-biased sex ratios, which would make sense given this giant looming female bias threat removing those individuals from the population. So next, we went into our second phase of modeling where we did something called population viability analysis. And what this did was we took our estimates for survival that we just got, grouped them with other estimates from past studies and expert opinions when we needed to, and we projected the population 50 years into the future under different management scenarios. And instead of going into all the details of how we structured the model, I want to focus more on how we integrated the impacts of different management strategies into these rates. So for our models, we considered 4 different types of management actions, and they all impacted something a little different in the model. But I think these are pretty intuitive. So first off, maybe the most logical solution, put up barriers. And this was expected to decrease the proportion of animals crossing the road. Next, we had our signage and other driver awareness education campaigns and other road signs that were expected to increase the survival of crossing females. And then finally, we had different predator and roadside vegetation management strategies that were expected to increase nest success, fertility, and recruitment into the population. So keeping these 4 different categories in mind, we created 3 tiers of holistic management strategies and evaluated what would happen to the population under each of them. And we started with the basic condition. What happens if we don't manage at all? Next, we estimated what happens under current management strategies where we have our signs in place, we have a small experimental roadside barrier out there, and some light vegetation management. And then using collaborations with our stakeholders, we co-produced with them 19 potential management strategies that included each a unique combination of actions across these 4 types. So to give you an example, one strategy may focus entirely on intensive roadside barriers and then have kind of light actions across the rest of these categories. And another strategy may include no roadside barriers and focus more on increasing driver awareness. So because we've done these population models, they now give us results that we can use to make decisions. And specifically, what we're looking at is the population growth rate and the probability of persistence under each of these management strategies. And to orient you, if you've never worked with these before, keep an eye on the population growth rate of 1 is equal to a stable population. Anything below that, the population is declining. And these results revealed 3 very important things. First, if we choose to do nothing, things are not looking good for the terrapin population. We predicted a very low probability of persistence and a rapidly declining population. Under current strategies, we saw that probability of persistence increase, but the population was still predicted to decline. And then across our 19 strategies, they performed variably well at maximizing terrapin persistence. So taking a closer look here, we can compare the best and worst strategies, and a couple themes really emerge. Our best strategies all included very intensive roadside barriers. They kept terrapins off the road. But they didn't just do that. They had a multiple focus. So they usually also included things like pretty intensive predator management and then also some different aspects of increasing driver awareness. But in contrast, these worst strategies, they all had a singular focus, they omitted those roadside barriers, and they tended to only focus on increasing driver awareness. So taken together, what these results allow us to do is prioritize the actions and the strategies that best maximize terrapin population persistence. Now these results have several implications, not only for the Jekyll Island Causeway, but also for conservation management at large. And first and foremost, it's kind of obvious, but there's really no substitute than keeping animals off the road in these high mortality cases. So hybrid barriers, different types of barriers should be designed and implemented, especially when we see concentrated areas of road mortality, which was the case on the Causeway. We also found that these untested sign strategies can have a positive effect on the population and help increase population growth rate when coupled with other actions like this. And that's the real take-home point, is that our results echo other studies where everything is complex and you simply can't just focus on one thing. You have to sort of consider grouping multiple strategies into a more holistic way to improve at-risk species. And lastly, I want to end with this. What I just talked about was estimating the consequences of strategies on terrapins. But of course, this is a human-wildlife conflict. So the next step will be to estimate what consequences these actions have on a broader suite of socioeconomic objectives that are important to our stakeholders. And these include minimizing cost and maximizing the satisfaction and safety of Jekyll Island's people. And only when we evaluate the trade-offs and all of these together, we can really come to conclusions about what strategies are optimal for Jekyll Island. So with that, I think we might have a little time for questions, and thank you guys so much for listening.